Dr. D. Govardhan, Professor in Department of Aeronautical Engineering, Institute of Aeronautical Engineering, Hyderabad. Today, we are discussing the topic mechanical properties of materials and Hooke's law in mechanics of solids. Whenever a wire suspended with the load, just it elongates. The elongations, it depends upon the amount of load that is suspended, nature of the materials, cross section area of the materials. But it is observed that when the load is applied at the end of the wire, it elongates afterwards. It will stop further elongations. It is due to the resistance force offered by the molecules for the elongation of the wires. If the resistance offered by the molecule, if it is less than the load applied, it is a further elongates till the fracture takes place. The resistance offered by the molecules to oppose the deformation of the body is called strength of materials. Sometimes it is also called mechanics of solids, solid mechanics, and so on. Okay, it is important to study the properties of the materials for the designing a product. The selection of proper materials enables the increase the life of the product, decrease the manufacturing cost, and the time required for producing the product also becomes less now. Here I am giving this brief introduction regarding product cycle of a product now. While designing any product, first it is required what is the need of the product, what is the applications, what is the estimation of the life, what is the cost that is involved. That is that entire just forecast is required now. So what is the product concept, what is the applications, how it is was, and everything is required. After completion of the literature of that product, design a product by using manually or by using the softwares. So when you are using softwares, that design is called computer aided designing. So after designing, if the design is perfect, it is analyzed whether it is works perfectly or not when it is kept in operations. That is when the forces are acting on it. So here in analyzing, the proper materials are also important, which decrease the cost of the product, increase the life, as well as the time required for producing the product is also less now. If it is a perfect, then computer aided drafting is required. The dimensions keeping the dimensioning, as well as the bill of materials and everything comes under here now. This part here it is called computer aided drafting CAD now. Afterwards, it is entered into the CAM now, the manufacturing. Here the proper selection of the materials enables what are the tools, that is the machine tools required, and what is the process planning required, tool load required, material testing is required, and CNC machines also required. After that, after completion, the product is checked whether it is withstand the forces or not, or whether it is as per the dimensions or not. That is the quality inspection is required now. Then it goes to marketing. Afterwards, take the feedback from the stakeholders. If it is any deviation is required, again, this will go for the product design once again, CAD process. Here the cost involving in machining process as well as the purchasing the materials plays key roles in selection of the materials. In selection of the materials, without knowing the properties of the materials, it's difficult to designer to select the proper materials. Afterwards, it should be readily available. The time is required in the machining process also very less now, very low is required. So here, the properties of the materials play key role in designing a product. The practical application in engineering materials in design and manufacturing depends upon thorough the knowledge of particular material properties under wide range conditions. The term property means it may be the qualitative or it may be the quantitative measure in response of the material externally imposed conditions like forces and temperatures. The classification of materials are one is mechanical properties, thermal properties, optical properties, physical properties, magnetic properties, chemical properties, electrical properties, and so on. Here we are not discussing only the mechanical properties. An engineer must have an intimate knowledge of properties and the behavioral characteristics of the materials for the designing and creating the new product. The selection of materials should be appropriate for manufacturing the desired product, which enables the reduce the expensive as well as the complex task. The mechanical properties, generally these are the properties of the materials which determines the behavior of it when the external forces are acting on it. They are usually related to the elastic and plastic behavior of the materials. The mechanical properties generally expressed as a function of stress and strain relations. The knowledge of mechanical properties provides the basis for predicting the behavior of the materials under different loading conditions. The mechanical properties are evaluated by the following tests. One is the tensile test, second compressive test, third impact test, and fourth fatigue test. Here the mechanical properties are the properties of the materials which are associated with the ability of the materials to resist when the external forces are acting on it. Okay, these are classified as elasticity, strength, stiffness, plasticity, ductility, malleability, hardness, brittleness, creep, formability, castability, weldability, fatigue, toughness, resilience, machinability, thermal conductivity, electrical resistivity, and electrical conductivity. Okay, all are not related to the mechanical properties. These are the properties are important for selection of right materials for the required product. Elasticity. It is defined as the property of the materials to regain its shape after deformations when the external forces which are acting on it are removed. General I told already, when a material is subjected to certain forces or the load, elongation is taking place now. Here the word we are calling here deformations because the dimensions may changes take place in the direction of the load that may be increases depending upon type of the load, example tensile, but at the same time, the dimensions which are there, breadth and width that are decreases, which are acting in transverse direction of applied load. Hence, here when the forces are acting on it, generally all the materials deformation taking place, but some materials may be there having the deformation negligible, some are maybe more now. But after removal of external forces, if, if the object is regain its original shape, that is the deformation disappears, then the property is known as elasticity. It is also called generally tensile property of the materials. This property of the materials is desirable, particularly in the machine tools, other the tools required for removing the materials or cutting the materials. It may be noted that the steel is more elastic than the rubber. The strength. Strength is defined as the ability of the material to resist the externally applied forces without breakdown or yielding. The property of the materials therefore determine the ability of the materials to withstand stresses which are acting on it without the failure. The strength varies according to the type of the loading, such as tensile, compressive, shearing, and torsional strength. Stiffness. The stiffness is defined as the ability of the materials to resist the deformation under stress or the load. The resistance of the materials to elastic deformations or deflection is called stiffness or the rigidity. The model of elasticity is the measure of the stiffness of a materials. A material that suffers slight or less deformations under the load has a high degree of stiffness or the rigidity. The higher is the value of Young's modulus. In tensile or compressive strength, it is called modulus of stiffness, modulus of elasticity. In shear, modulus of rigidity, and volumetric distortions is a bulk modulus. Plasticity. The plasticity is opposite character of elasticity of the materials. That is, elasticity is defined as the property of the materials regain its original shape after removal of the external forces which are acting on it. But here the plasticity is defined as the mechanical property of the materials that retains the deformations produced on the load permanently without rupture or failures. That means here after removal of the forces, it will not regain its original shape. The deformation which is produced, it is retained as it is only. Generally, this deformation is taking place for the any materials when it is deformed behind the elastic limit. This property of the material is most important in manufacturing processes such as forging, stamping, images on coins, and ornamental work. The materials such as clay, lead, etc. are plastic at room temperature, and steel is plastic at forging temperature. This property generally increases with the increasing in the temperature of materials. Ductility. The ductility is a termed as the property of the materials, enabling it to drawn into the form of wire with the application of tensile load. A ductile materials must have strong and plast. The ductility of a material is generally measured in terms of percentage of elongations and also percentage of reduction in area. The materials that possess more than 5% elongations are called ductile materials. If the elongation is less than 5%, that material is called brittle materials. The ductile materials commonly used in engineering are mild steel, copper, aluminium, nickel, zinc, tin, and lead. Here, already given, if the elongation is less than 5%, then these are called brittle materials. The example for the brittle materials are ceramics. Malleability. Malleability is the ability of the materials to be flattened into the thin sheets under the application of heavy compressive forces without cracking by hot or cold working. It is a special case of ductility which permits materials to be rolled and hammered into thin sheets. The malleable materials commonly used in engineering practice are lead, soft steel, wrought iron, copper, aluminium, tin, lead and steel. Hardness. Hardness is the ability of the materials to cut the another materials. Or it is also taken as it has resistance to crack when another material is moving this over it now. It is an important property of the materials that has a very wide variety of meanings such as resistance to wear, scratching, deformations, and machinability. The hardness is usually expressed in numbers, determining by following the test: Brinell hardness test, Rockwell hardness test, Vickers hardness test, and Shore Claroscope. Brittleness. Brittleness is the property of the materials which is opposite to the ductility. The ductility already given, it is the ability of the materials to drawn in the form of vice now. It is the property, the brittleness is the property of the material, breaking of a material with a permanent distortions. The materials having less than 5% of elongations under the loading behavior are said to be brittle materials. If the metal cannot undergo any deformations like glass, china, ware, and etc., when the external forces are acting on it and it fails by ruptures, it is called brittle materials. Example: ceramics, glass, cast iron, brass are considered as brittle materials. Creep. When a metal part, when it is subjected to high constant stress at high temperature for a longer period, it will undergo slow deformation. Slow and permanent deformation is called creep. These properties are considered in designing, such as internal combustion engines, boilers, and turbines. Formability. It is a property of the materials that it denotes easy in its forming into various shapes and sizes, such as by taking the sheets, we can make it in the form of cylindrical vessels, boxes, or the funnels, and so on. It is a property of the materials which can form into different shapes by the application of the tools now. The different factors that affect the formability are crystal structure, the grain size, and at hot and cold working conditions, allowing element present in the parent materials. Castability. Castability is defined as the property of the metal, which indicates with ease with it can be cast into different shapes and sizes. The cast iron, aluminium, brass are possessing good castability. Here, in order to make the product in a bigger size, having sharp absorptions, generally that are made by using the cast iron, the process is called air casting now. Here it will take less time and the manufacturing, the cost which is involved in manufacturing is also very, very less. By taking proper care, the problems, that is the defects which are associated in casting, that can be minimized. Hence, the castability is the important factor for the designing of a particular bits of heavy machinery. Weldability. Weldability is defined as the property of a metal which indicate the two similar or dissimilar metals are joined by fusion with or without application of pressure and with or without using of filler materials. Generally, the weldability is the most important for the fabrication of bridges, sheds, and a machinery bed also are doing, and also some important parts of assembly also can be done by using weldability. So in weldability, if the metal is having good property of weldability, by the application of heat as well as the pressure or without pressure, by using filler metal without filler, we can get the desired shape of the product, which is having stronger and also it can withstand the forces when they are acting, maybe in rest or in motions. The metals having weldability in descending order are iron, steel, cast steels, and stainless steels. Fatigue. When a metal is subjected to repeated stresses, it fails at the stresses below the yield point stresses. This type of failure is called fatigue. Toughness. It is a property of the materials to resist the fractures due to high impact load, like hammer blows. The toughness of the materials decreases when it is heated or at elevated temperatures. It is measured by the amount of energy that unit volume of metal has absorbed without rupturing when the load is acting on it. This property is desirable in parts subjected to shock and impact loads. The toughness of the metals decreases when the temperature of the part is increased. Resilience. It is a property of the materials to absorb the energy, to resist the shock and the impact loads similar to the toughness. It measures the amount of energy absorbed per unit volume within the elastic limit. This property is essential particularly for the designing of springs. Machinability. It is the property of the materials which refers to relative easy with which materials can be cut. It is measured in number of ways, such as comparing the two life for cutting different materials are thus required to know the materials to some given rate or energy required to remove the unit volume of the materials. It may be noted that the brass can be easily machined than the steel. So the selection of machinability is the most important, where the desired product can be obtained by the removal of materials by the different operations. The proper selection of materials enables the time required for producing the product becomes less, the cost involved is also less, the energy required for removing the material should be less. It will also increase the life of the tool now. Hence, the proper materials is the most important. It is also depends on selection of machine tools. Thermal conductivity. This is the ability of the materials to transmit the heat energy by conductions. This property is most useful in designing internal combustion engine parts. Electrical resistivity. It is the property of the materials by which this is the flow of electricity through it, and these materials is most useful in designing electrical parts where the electrical resistivity is required to minimize the electrical shocks and so on. Electrical conductivity, it is a property of the material due to which it allows the flow of electricity through it. It is the opposite character of electrical resistivity. Okay. Without knowing the properties of the materials, it is difficult to select the right materials to get the proper product which is having more life, less expensive, and also the manufacturing procedure what we is following, it becomes easy now. Hence, as a designer, yes, having thorough knowledge of material properties, otherwise it is difficult to get the proper product. Hooke's law. Okay, it is important law for studying the mechanical properties of the materials. It is stated by English scientist Robert Hooke in 19th century. He observed that many materials exhibited similar property when it is subjected to external loads. When he studied the stress-strain relationship between all the materials, all are having the exhibit similar properties. This property is kept in the form of laws. It is known as Hooke's law. This Hooke's law gives the relationship between the stress-strain of the materials when it is subjected to loads now. The Hooke's law states that when a metal is loaded within the elastic limit, the stress is proportional to the strain produced by the load. That means the ratio of the stress to the corresponding strain is always constant. Mathematically, if stress is represented by sigma and strain is represented by epsilons, that is the ratio of stress to strain for all the materials, for the most of the materials, it is always the constant. This constant generally it is expressed in the form of this E now. That is stress by strain is a constant for the materials. This constant is known as modulus of elasticity, modulus of rigidity, or elastic modulus. This values is different for the different materials, but for the particular materials, when the load is, it may be compressive or the tensile, the ratio of stress to corresponding strains remains constant. It may be noted that the Hooke's law equally holds good for the tension as well as the compressions. Here, the value of E for certain materials are given in below. These values are constant when the object is subjected to tensile load or compressive load. Here, steel is given depending upon the materials, some composition it is there now. Generally, it varies. Generally, it lies between 200 to 220 GPa. Wrought iron 190 to 200, cast iron 100 to 160, copper 90 to 110. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.